Hi friends, welcome to OFA Studies YouTube channel. This is continuation to the Fabric playlist. In our last video, we have discussed about data science, like how the data science will work actually in theoretical way. But now in this video, we are going to create some AI model using the data science within the Fabric. Okay, so this is like a kind of a practical session where we will create a model uh, that built from the data what I provide. Okay, so I will do machine learning and all that stuff. So let me quickly explain you how it will happen first, and then I will show you practically as well. So first thing is, since we are going to do it in a Fabric, we should have a workspace. Okay, so once you have a workspace, inside the workspace we will create a notebook. Okay, and why we will create a notebook is we wanted to perform certain tasks using the notebook. First thing is we wanted to get the data. So in this example, what I will do, I will try to refer Azure Open Datasets. So what is Open Dataset? Open Dataset means Azure, the Microsoft team has provided some dataset ready-madely available for you guys to go ahead and explore. So we will use that Azure Open Dataset. Especially we will use the diabetics dataset. Okay, uh, and then we will get that data into the data frame. So once I got that data into the data frame, then what we will do, we will clean that data according to our own needs, because we have to structure the data in a well formatted before take the data for the training purpose. If you want to make sure your training goes effectively and your model has to behave effectively, then your data should be more quality. Okay, so we will clean the data, and then once we do that, what we will do, we will try to train the model with that cleaned data. And when we are training the data, what we will do, 70% of the data we will use for the training, and maybe 30% of the data we will use for the testing. So the process of model creation will happen this way. So it will take 70% of the data, you can decide that percentage, but ideally, and it will train the model accordingly. And the remaining 30% it will use it for the testing purpose to see whether the model predictions are matching with the actual numbers or not. Okay, so once you have that, what you have to do, you have to create something called experiment in Fabric using the ML flow. Okay, and how this model will get create actually, this is using there is something called scikit-learn library in Python, because I am going to use a Python. So this library help you to train the model using various algorithms. Okay, and you need to create an experiment once the model is there, and inside the experiment only the training actually happens. Okay, and once that training happens, you will open the experiment, and you will observe the results there. You will observe various matrices to see how your model is looking like. It's kind of a scoring, imagine that way. So if your matrices are looking better, then you will decide, okay, I'm going ahead with this model, and you will save that entire thing whatever you built as a model. So once you save that as a model, people can start consume that model by they can give the real-time data to it and ask the predictions out of it. So this is the whole steps what we are going to perform. So let's do this practically. So step one is getting the data into the notebook, but we should have a what to call, we should have a workspace and we should have a notebook. So let me go to my browser and let me open the Fabric workspace. So I'm app that fabric.microsoft. If you go to that URL, you will have your workspace. So let me navigate to my workspace. In this workspace, I am hitting this new item button to create a notebook. So I can filter for notebooks from here, as you can see here, right? So I am searching here, so I can filter notebooks from there. So let me type notebook, and I can use any of these notebooks. I am selecting one of them to create a notebook there. And once my notebook gets created, I have to get the data from the open data source. So this is my notebook, and if you observe it clearly, uh, this is where I will kind of write my code, and when I hit this button, it will actually execute the cell whatever the code I written there. So I will use a default Python language. So you can see that Python language is already selected there, right? And You can also hit this run all button to run all the cells in the notebook. We have discussed these things in our previous videos of a fabric, so please watch them to get more familiarity. So first thing is, and also we have discussed there is something called markdown language and the code language where I can write a code also. Both kind of a cells are available. So I'm not going details about it. Watch my previous videos in a fabrics to understand. So step one is get the data. So to get the data, I said I'm going to use the open data set. So if I click this link, don't worry, all these steps and script I will provide inside the description of the video. You see the code written here which I am going to use now. So everything will be provided in the description of a video. So let me hit this link to see the open data set. You see we navigated into the open data sets, and right now we are in the diabetics data set, and it will explain what columns it will have. So all these columns open data set contains. Okay. uh, and the preview of the sample data, everything will be available. So this is a diabetics kind of information. Let's try to spend 1-2 minutes to understand the data. And if you see here, we have a age column, and also we have a couple of other columns. So from here to here, right, all these columns, something like a parameters, like what we wanted to use it, and this is actually like a label column. So what is the meaning of the label column or parameters? So ideally what will happen, so take this example, let's assume you wanted to predict the monthly sales. So you will be training the data, right? So you will be having a months like January, February, March, and you will be having a sales here. So 10 sales, 20 sales, right? So this is like a this is like a x to the function what you pass. This is like a y that will get predict. So you might be knowing this x comma y, this kind of a mathematical expressions, right? I'm not going details about it. So x values were always like which I will be passing to the model, and y is a label that will actually get predicted from the model. So if you see this example of the diabetics right now, I am going to consider all these values as a x. Okay, and I am going to consider this value as a y. That means the label, but not exactly y. Actually I will be creating another column called risk. That column I will be going to consider as a y to the function. So what I mean by that, so what I wanted to see, because this is a diabetics related information. If you see, this is like a diabetics value, like how much diabetics a person has, something like that, right? So the y-axis. So when I say this, the column y actually contains the diabetics related points or the measurement. So what, and when you see this preview data, so let me keep this. So when you see this preview data, we have various y values, right? So how can I decide which value is a diabetic, which value is a non-diabetic? So what I will be doing it is, I will be creating as the process of cleaning the data, I will the step one what I will be doing it, I will be loading this whole data into the fabric, and then I will be creating one more column called risk column, and I will be having some threshold, uh, uh, and based upon the threshold, let's assume 212 is my threshold. If any value greater than 212, then that is high risk diabetic. Okay, high risk diabetic. If any value less than 212, that is like a low risk diabetes. So I am going to predict that. So in future, if I have more humans information with the diabetics numbers, I will be giving that to the model, and model is going to reply back me whether it is a high risk diabetic or a low risk diabetic. So I'm going to do the classification algorithm here. So basically I'm not going to predict what is the diabetic measurement number a human is going to have. I am going to predict actually risk, like I will be getting even the y column value also, and then finally I will be predicting the risk column where it will says value either 0 or 1. 0 means a low diabetic, 1 means high diabetic risk. Okay, so this is like classification. My prediction is going to be either low or high, so we have to use a classification algorithm here, and the classification column or the label column is going to be the risk column, which I will add based upon the values what I have in the y column. So when I practically implement that, you will come out of the confusion if it is all confusing now. So let's go ahead and do that. So let me go to here my one node, and let me copy paste this code. This whole code is going to refer that sample Azure open dataset of the diabetics and try to load that into a data frame. So let me copy this whole code, and then let me go to my here the notebook. So I'm pasting this whole code, and if you try to understand this code, so let me correct this code. Okay, so let me correct this. So if you understand this code, what we are going to do it here is, so we have taken this storage account name. This is a publicly accessible storage because it is a Azure open dataset. We have taken the container name. We have referred the path where the diabetics database or the open dataset is available. And SAS token for the storage account we no need to pass because this is open dataset. Anonymous access is allowed there. Then we are framing this WASBS path, and we are setting that SAS token also into the Spark configuration. And finally, we are trying to read that whole data and then displaying the data frame here. Okay, so one second, I have to correct this code. So this is where we are reading the data. So if you observe this, right, so this is where we are reading that data from the diabetics open data store, and we are loading it into a data frame, and finally we are displaying the data frame. So let's run this code now. When I hit this run cell, initially it will start the session here, and once the session loads, it will show the data frame also below after loading the data into the data frame. In this case, my data frame name is df. So let's wait for this execution to finish here. You can see the execution got completed, and you can see all the data here. So if you see here, I have various columns here, right? Like age column, BMI, BP, S1, S2, S3. So I have various columns along with the Y column, which the Y column actually tells us like how much, what is the diabetic measurement right now the person has. Okay. So what I wanted to add one more column and define whether the first row is a low risk diabetic or a high risk diabetic. Then the second row is a low risk diabetic or the high risk diabetic. So how I am going to add that low risk or high risk values? So what I will do, I have various values under the Y column here, right? So what I will be doing it, I will be taking, let's assume I have values from 1 to 100. So the 75th percentage value, whatever we have, I will take that as a threshold, and anything more than that is a high risk, anything lower than that is a low risk. So that's what I wanted to define the logic. So how I will come to know what is that 75th percentage value? So I have, for example, if my measurements are 1 to 100, then I can say 75 number is the 75th percentage value. But now I have a random numbers, so which is the 75th percentage of the value? So to know that, right, there is a easy way. So what you do, firstly, let's convert this data frame into a pandas data frame. So let me convert this into a pandas data frame. So I am going to add a new cell here, new code cell, and I am converting this into the pandas data frame. And after I convert, what I will do, I will use something called head function just to display sample 4 rows to make sure my data frame converted into the pandas data frame. So I am running this cell, and let's wait the data frame to convert into the pandas data frame, because the previous data frame what I created, it's a Spark data frame. Now I am converting into the pandas data frame. So it got converted into a pandas data frame and shown some values. Once you have a pandas data frame, let me use, there is something called describe function. So when I use this describe function, it will basically tells me a lot of information. If you see here, this column, right, you see the 75th percentage row also it is indicating it, and 211.5 is my 75th percentage value. So what I will be doing it here is, on my data, wherever, see here, right, wherever I see a value lower than 211.5, I will be marking it as a low risk. That means value 0 for the risk. If a value is greater than, for example, 310 here, right? So okay, if you guys are not able to see that, so let me do this here. So you see this value 310 here. So for this, the risk column value is going to be 1. That means a high risk. So that's how I will add a new column, and that new risk column I will be treating it as a label column. So let me do that. So to and also before not only that describe functionality, I wanted to show one more thing. You can use something called a box plot. So I have this data frame visible here, right? So you click this new chart here, and then once you click that, you should see there is something called build your own. So click that build your own button, and then here, right, I will be selecting the chart type box plot. See, I have changed the chart to box plot, and then the y-axis value I am going to select the column y. See, the moment I selected column y as a y-axis and also box plot, you will be seeing a visual here, the box plot. And if you closely observe this visual, when I hover it here, it will clearly tells me all the values, the starting value of the y-axis starts here and ending value is this much. The starting value, the minimum value of the y-axis column was 25 as per the tooltip, and the maximum value of the y-axis is 346. Okay, so you can see that in the visual, right? So let me zoom that and show you that. Okay, so one second. So let me zoom this. So you see this, right? So this is like a maximum value 3 346. That means this side, minimum value 25 is a that side of the box chart. And also if you observe uh, here, right, when I hover on the tool tip, you see this line. So this side it is called 25th percentage value, this side it is called 75th percentage value, and this is like a median. That means between this 25th percentage and 75th percentage values, half of the values are this side of this value, half of the values are this side of this value. That's what this median denotes. Okay, so all these values will be available in the tooltip if you can observe it. So let me show you that. See, the median value is available, the lower quarantine, that means 25th percentage value, the upper quarantine, that means the 75th percentage value. All the values are available there. So even here also you can see the 75th percentile is 212, but it rounded to 212, but as we have seen using the describe function, it is 211.5. So we will take the 211.5 as a threshold to calculate somebody is a high risk diabetic or a low risk diabetic. So how to do that? So how to add the new column on top of this pandas data frame? So to do that, so I have a code already. So let me go ahead and copy this code and let me paste it here. So what I am doing it here, I am adding a column called risk. Okay, and I am taking the y column and I am telling anything value more than 212 is a 1, otherwise 0. So that's what I am telling. So let me change this threshold value to 211.5. So once I do that, let me execute this code, because 2115 is the threshold what we have decided, right? And you can see that here also, right? That is a 75th percentile. Okay, so code executed successfully. Now let me try to display the data frame. So when I execute this code, now you should be seeing the risk column here, right? You see the risk column here. So you got the values zeros and ones. Okay, and you can see probably this is the value 1. Okay, that means a high diabetic, because the value is 310 there. Okay, so now this risk column I am going to treat it as a label column which model is going to predict. So I have cleaned the data indirectly. Basically I have cleaned the data. So I got the data from the Azure Open Dataset and I have performed the cleaning. So now what is the next step? Next step will be split this data and perform the training via experiment and save this as a model, right? So how to do that? So let me go back here. As I said, right, I will be using something called scikit-learn library. So that library is a Python library that help you to perform this machine learning algorithms and do the training. So first step is, let me copy paste this code. This will help you to split the data. So my data is a data frame df, right? So I copy pasted the whole code. Now if you see here, right, so I am basically taking this library and then I am splitting this data frame into x and y parameters. So I should use a data frame called df, because df is my data frame name, and I have mentioned all the column names also here, and also I have mentioned which column is going to be my column where I'm going to predict. Okay. So let me change the data frame name to df. I'm not going details about this code because the idea is not go through the details about how to write a code and all. So I'm just copy pasting it. You guys refer the same code from my description, but in our future classes we will try to understand these libraries in more detail. At a high level, understand that I am taking that whole data frame, I am splitting few columns as the x to the function, few columns as the y to the function. Y means in this case a label which my model is going to predict. So risk is the column, the only column which we are going to predict. And also I am kind of setting some threshold saying 30% of the data for the testing, remaining 70% is for the training purpose. So let's run this code. That way we are performing the data split accordingly. Okay, so once the data split, once the code executes completely, let's go back and do one thing. Let's create a experiment using ml4, because you need to have an experiment first. Inside the experiment only you will train the model. Okay, so copy paste this code which imports the ml flow. So let me hit this new cell, and when I paste it here, right, if you see, I'm importing the ml flow, and I'm creating an experiment with a name called diabetics hyphen classification, because I'm going to classify either 0 or 1 values. Now using this ml flow, there is something called set experiment function that will create an experiment in my workspace. So the moment I run this code, it will create one item inside my workspace with that experiment name. We will see that in just a bit. So let me run this, and it should create a experiment inside my workspace. It should have been created it, but it's an empty experiment right now. We should be uh, training the data inside this experiment. So you see the experiment created successfully. Now let's add a new code cell. The data whatever I have prepared so far, I am going to use that inside this experiment to train the model, and especially I'm going to do the classification training. Okay, so let me copy paste this piece of a code where I am going to use the scikit-learn library to do that my training. Okay, so now if you see here, right, if you see this piece of a code, I am using logic regression algorithm. This is the algorithm what generally we use for the classification. There are so many other algorithms, but as I said, let's not go through in details about a code. Understand a high level what each step is doing. So basically here I am taking some algorithm and giving my data which I splitted, right, the 70% 30% to that algorithm, and asking to perform a machine learning there, the training process there. So once the training process completes, inside my experiment which I created, I can see the results of the training. If I feel satisfied with the training results, I can save that model and start consuming it. So let's run this piece of a code now and wait for the execution to complete. It will not take much time because we have, it's not a huge database, sorry, it's not a huge data. We are using a simple data only. So when this is running, once this entire thing completes, as I explained here, we will be going and exploring the experiment inside our workspace and observing the run metrics values. If we feel good, then we are going to save it as a model. Otherwise people can once again train with a different type of a data and see if that time results are good, and accordingly save the model. So let's go back to my notepad, sorry, my notebook. You see that my run completed for the training, and I see the status as finished. Everything looks good. Let's go and explore this experiment what I created. What is the experiment I created? Diabetes classification. Inside the experiment only I perform this training. So I need to go inside that experiment. So where to find that experiment? So go to my workspace, and now you see the diabetics classification experiment there. So this is what it got created just now, because we have given this name, and inside this experiment we have performed that training and everything. So let's open that experiment, and when I open that experiment, I can see how the training happened. The some results I can observe. So ideally these are the results which generally people observe. So this run matrices. So what is this run matrices? Again, this is data science terminology. Whenever you train something, there are certain flag values. For example, all these are like a various flag values for the classification algorithm. So there are certain measurements. If this particular flag value is into certain range, then it is a good model. If this particular flag value into certain range, then it is a bad model, something like that. There are some fixed parameters depending upon an algorithm what we use. So one need to have that idea to judge whether based upon these scores, these metric values, whether my model is looking good, or I should consider taking a different data and train it once again. So that judgment people has to do by seeing these matrices values. So assume that in this case everything is good. So once you feel all good, now this is like a training results. Now model is not created yet. Only experiment created. Experiment is a container in which you will train the model. So once, if not only one time, you can train multiple times. Once you feel a specific run, for example, whatever the run I executed, you see that here. If you add more, once again, if you train inside the same experiment, another entry will come. Whatever the entry you will feel more better based upon the matrices, you can save that as a model. So assume that in this case, this results looks fine to me. So I'm going to hit the save as model, and it will ask you to, so I'm going to go with a create new model. So select model folder. Okay, and I can give any name, model name. So I will be saying model diabetics hyphen classification maybe. Okay, classification. So I gave a name to my model, and I'm hitting the save button. So this actually creates the model, and in future you can use that model to perform your predictions. Okay, so let's wait for this model to save it here. So you can see that model creation is in progress here. Once it finishes, either you can click this view ML model button or navigate back to your workspace. You should see a model here. Okay, awesome. You see this? See this? This is an experiment what we have created it, and this is the model what we have created it. You can observe the difference between icon. Experiment has this kind of an icon, model has this kind of an icon. So once your model ready, you can go inside of a model and you can see the metadata about this model. When I say metadata, which experiment created this model, all that kind of information you can see it there. So let me refresh this model here, and you see when it is created, it is a version 1. Let's assume your experiment got another run, you wanted to save that another one as a one, once again with the same name. When you same another model with the same name, it will create something called a version 2. Okay, so every version will have one version added here. How many times you do, that many model versions will come. Okay, so not only like how to run this model, right? So we are not going to run it, but basically like how we written a Python code in notebook to create this model. I mean basically to create an experiment and then to train the model. Same way, once the model is ready, you can write a code inside your notebook to do that. And when you hit that copy code, you will see a sample code that using ML flow you can run the model also what you created. So this sample code, if you want, you can copy paste into your notebooks and then replace the input data here with the latest data what you want to pass and get the predictions out of it. And predictions whatever you got, you can save them back into the output location what it is pointing here. I'm not going to try this, but yeah, but there is a way. Once the model is ready, write the code in your notebook and do that predictions accordingly from the model. Not only that, you can hit this apply model using wizard as well. When you do that, it will ask you from your lake house, take some table which you want to pass it as an input, and then map the columns accordingly, which columns are the kind of a parameters, and then finally map the outputs and get. And basically you will not write any code, you will follow this wizard and you will get the results of the model predictions. Okay, so that's it. I think you have understood how to create a AI model inside the Fabric. Step one, we will be getting the data. So of course we will be using a notebooks for doing anything, and using a notebooks. Step one, we will be getting the data. Okay, so in this case Azure Open Dataset we have used. Then we will be cleaning the data. In our case, we kind of added that risk column which we wanted to predict. Then step 3, we split the data for the model training and testing 70 and 30 percentage. Then step 4, we will use the ML flow to create the experiment. And step 5, inside the experiment, we will be training the model using the respective algorithm, and we will use scikit-learn library from the Python, which has various algorithms. And finally, we will go and observe the experiment results, matrices mainly. And if all feels good, we are going to save that model. So that way we are up and running with a model which has an artificial intelligence in it to predict the data, to predict the values whatever you pass to it and request the predictions back. So that's it in this video. I hope you enjoyed this video. Thank you for watching. Have a nice day.